update on the POSIX extensions, and also I'll give you a little bit of background on the client as well, because there's some fun things. And a lot of the people here are familiar with some of the fun stuff, so I think it'll be enjoyable. So I want to talk, one of the things that I love talking about, because I think even you may have mentioned POSIX once or twice. Somebody's probably mentioned libc once or twice. You know, Linux is not POSIX. One of the fun things I had was I was looking at the syscalls. So you guys have probably looked at this, right? Do a git grep syscall define, 850 of them. The FS layer has 223 of them. So the problem we have as file systems is so much harder than the block device guys. Like 223 syscall defines, how many does the block layer have to deal with? I bet it's less. So, you know, think about POSIX. That was 100 syscalls roughly. And you know, some people say, well, they're not documented, and some are just duplicates of one another with minor changes. But I mean, come on, guys, there are 513 man pages already for the syscalls in Linux versus 100 for POSIX. So our job is kind of tough if we're trying to make a network file system work as well as TED's ext4. This is not always trivial. So you can say, oh, but this is all old stuff. Well, you know, IOU ring, great stuff, right? It wasn't the only thing added. You know, Dave Howells keeps trying to add stuff, right? LWN's lead article was 3 more, right? We're adding more. So some of these don't directly affect a network file system, but at the same time, this is just 1 year of stuff, right? So every year. So imagine how long an RFC takes to get from like IETF start to finish. If we had to do an RFC for every one of these new things, we'd be dead by the time. So the point about all this is Linux isn't POSIX. We got a hard job in file systems. We got to move quickly, and we have to be able to support Linux well. And it's not just new syscalls, by the way, guys. We add flags. I just took 2 examples. fallocate, you got 7 flags. Rename, 3, excuse me. Needless to say, in POSIX, none. So we got a lot to do. And you know, a lot of the talks yesterday and some today were about local file systems, and that's great. Network file systems still matter. There are certain things, I remember discussions at the File System Summit about RDMA and how you lock pages, and a lot of this is because when you're not using a file system, it's harder to make consistent metadata to deal with leases and locking and security issues. So network and cluster file systems matter for a lot of workloads, even if they're non-optimal performance in some cases. So what's our goal? We got to make sure these extensions actually work. So let's give a very quick overview of the status. So some good stuff happened since last year. So today with the 5.1 kernel later, you can try this stuff. You use the mount option POSIX on the client, if you're using the kernel client. Read dir works, create, make dir, statfs, all that stuff works. The one piece that's in flight is query info. That required a fairly large amount of restructuring. And also, we'll get to this about reparse tags for special files. Samba has an experimental tree. Go to samba.org, you'll see Jeremy has this master SMB2 branch, experimental tree. Volker, there's Volker, he did work on the SMB client. So in the SMB client, you can create using these POSIX extensions as well and get these POSIX-like features. There are some additional options that could be added. For example, a POSIX LS. There's a few things that could be added on the client, but most of this is done. In addition, there's a kernel server. And you know, I love how fast these things are working. So I'm sitting listening to Jeremy's talk, and I just had this brilliant idea. Am I really sure the kernel server didn't actually implement the POSIX extensions? Well, they did. So I was kind of embarrassed because we've been emailing back and forth with Namjay, talking about check patch and the normal maintainer kinds of things, giving him advice about, no, don't do that, no, get rid of that ifdef. So we've been trying to help these Samsung guys to make their code look more friendly to Samba guys and more friendly to kernel guys. But I hadn't thought, like, maybe they had actually implemented quite a bit of the Unix extensions, the POSIX extensions already. So I noticed that while I was talking to Jeremy, or while I was listening to Jeremy, excuse me. So SMB3 kernel server, it's pretty far along. We've been setting up automated testing for it and doing some review to see if it's good enough, and I think it is at this point. So we'll see if we can help them push it forward. This is not a replacement for Samba. I don't mean to make it sound at all like that. A lot of what we're seeing, though, is that it's extremely useful when you're trying to prototype things. It's been great for error injection for Ronnie, for example. It's been great for us to do some certain types of experimentation. It's not great for clustering. It's not great for access control. It's not great for all the RPCs. It does support some, but this is very exciting to have multiple servers to try against. 2 weeks ago at the Storage Developer Conference, there was a third-party implementation as well that supports these POSIX extensions. These are all experimental, but we only have 1 or 2 little to-dos to finish off on this one to say, it's no longer experimental. And of course, the things he alluded to in his last talk that are kind of delaying some of the Samba work. In addition, Wireshark, the network analyzer, has patches available to decode all this stuff. And there's user space test cases in Pike. So let's back up a little bit. Jeremy had a talk about Samba just now. Now, my client perspective, why Samba matters. Well, any disagreement with those? I mean, it's everything. When you have something that's almost 4 million lines of code and has everything you could possibly need, the problem is no one human understands it, but everything's there. And what is so cool about it is the video player on Linux has an embedded SMB client to access Samba. I'm just saying that whether it's great or bad, I don't know, but everything has this stuff that accesses Samba. So it's like, what do you do? It's like you can't avoid these clients whether you want it or not, and Samba is sort of like a common language across the universe. You're sitting, some crazy person has a Mac. I assume 1 or 2 of you have ever seen Macs, right? Their preferred protocol is SMB. So the Mac developers were there, a few weeks ago, right? So, their iPhones and their...
Yeah, whether you, just borrow that. Yeah, the Mac... The Mac guys implemented the Microsoft Search protocol in their client. That's how their Spotlight Search now works. And Samba's the only third-party implementation of the Microsoft Search protocol as well. So we kind of all test each other's stuff together, as you can see. Moving on to the next slide.
Yeah, and so you might recognize a few of these people. So go ahead. Question. Yeah.
Yeah, pretty much they use an SMB call to upload to invade the alien mothership. Yeah.
By the way, one of the things we talked about in earlier presentations, I think a year or 2 ago, but we want to emphasize is that the Macs do have their own POSIX Mac extensions, right? We chose not to use those. So that was not because they weren't bad. They were bad for them, but
I can answer a little bit about the reason we didn't do that. This is Apple, so they kind of developed in isolation without talking to anybody. They just did the things that they needed and nothing else, which is kind of typical. And the other thing is they mangle the protocol in some unpleasant ways, which we used to do in the SMB 1-year extensions, but we've made a deliberate decision not to do that for SMB 3. We wanted to have in fact, let's keep moving because
and we'll go through some of the.
Minutes.
We'll go through this very quickly in a few slides. But one of the things that was a design principle that Jeremy obsessed about, probably correctly, was that if there was a protocol feature that was 98% of the way there,
it's good enough.
Use it, and
don't
try
add
to
new stuff.
Don't try to invent a POSIX info level 101 because you thought the field name was not pretty or you would have liked it. So there's a lot of things where we used existing features in the protocol, tried to add the absolute minimum. And
the other thing was never send back the same information twice. So you've got a Windows call that sends back the timestamps, even though they're not 100% Unix semantic timestamps, they're good enough. So if you get timestamps back in a Windows call, use the Windows timestamps. That's fine.
Okay, so let's look at some specific stuff. The POSIX extensions are actually really easy to understand. We have a negotiate context we send when we set up the connection to the server. If the server could possibly understand POSIX, it's going to respond with the ID, the open context ID that it supports. So there's the negotiate context. And it has a field that indicates the ID. On the opens itself, so here's a create request. If you look at the create request, it has a context. That context.
The reason we do that at session setup time is because the POSIX extensions are negotiated on a per handle context, and the server is allowed to reject them if it so requires. We needed to have a way to find out whether the server was rejecting them because it didn't understand POSIX at all, or whether the server was rejecting them because it chose not to grant POSIX semantics on this particular share. So for instance, if you've got a share that was running off a file system that was case insensitive, for instance, it's hard to do POSIX extensions on a case-insensitive share, so any opens requested POSIX on a case-insensitive share, they would just not grant the POSIX handle extension. They would not grant the POSIX handle back, and you'd have to fall back to using pure Windows semantics.
And Apple has a similar kind of thing with, they can have cases where an app is requesting POSIX or not POSIX. I think that that's not as much of an issue for
But theirs is really ugly.
Yeah, it's very, very ugly. But in our particular case, this works very simply. You have a context that is sent. If you respond, you could understand POSIX, and then on any particular open, we can request POSIX semantics. And we don't request POSIX for every open right now. Now, if you look at the details of it, it's actually quite simple. You see how small this blob is at the bottom. So it's not a complicated thing. Now, smbclient, we talked about Volker's work. Here we are. If you look at the help, you can see the POSIX extensions in it, and you can do the POSIX remove, you can make things with the mode bits in it. So many POSIX features are already in smbclient. So I want to switch gears very briefly. So a lot of you guys work on file systems. A lot of you guys work on the Linux kernel. Hopefully many of you guys work on the Linux kernel. We've had a lot of progress in the last year. I wanted to give a little bit of context here. We have the file system coming up again. Here's last year. You can see Ted and some of the other people. A lot of really fun progress. One of the reasons that we talk about these extensions as so important has been there's a huge activity that's been going on in the SMB side the last 2 or 3 years. Of all the file systems, it's the third most active, right? XFS, ButterFS, and SMB. And file systems are one of the most heavily analyzed parts of the kernel, so this stuff kind of matters, right? People don't think about file systems as much because they've been around for so long. A lot of the focus has been on NVMe, but these are really active, XFS, ButterFS, SMB. Look at the change activity on these guys. And back again, Samba's activity is as big as all the file systems put together. Samba's test cases are bigger than almost any server out there, just the test cases. It's 3.5 million lines of code. So that's kind of gives some context why we focus so much on these SMB POSIX extensions for the kind of common language, the commodity protocol to get all this crazy amount of storage in the world. If you want to use this stuff, you need this patch, or you need a 5.1 kernel or later. Here's an example of doing readdir. One of the things you can notice on readdir is that we're returning mode bits properly. So that's, that part works. The query info is an example that isn't quite complete yet. When you make dir or create, all the mode bits are preserved properly. Here you can see them on the local version of the drive and remote mount. The mode bits were preserved. A lot of our focus, though, has been on testing and trying to find out what's broken. So we have this thing called the build bot. The build bot has been doing automated testing to a large variety of servers. It now includes running Jeremy's SMB server, not just Samba and Windows and Azure and all the various types of servers in the kernel. The KSMBD, the SIFSD kernel server is also in there. So we have all these server targets, and the number of test cases we're running is about 150 of the maybe 250 that we could run for a local file system, or for a network file system. But this has been incredibly invaluable. For the POSIX extensions, we're up to about, I think, 80, something like that we can run. And some of our focuses have been on finishing that up. So today, what could you try? If you're running with the 5.1 kernel or later, you're by default mounting with verse equals 3.1.1, so that's not an issue anymore. You specify one option, POSIX. Typically, you would also not want to remap POSIX characters into a remap marriage. There's no reason to do no map POSIX if you're using POSIX because you don't need to remap characters. So typically, you'd use no map POSIX to remind you not to bother to remind the server you don't need to. On the client side, we're not going to attempt to remap these characters. The server will handle them. The only pieces that aren't going to work is when you do let's say you have a FIFO or a block device, those won't show up properly. and stat output can report the incorrect data because that code isn't quite finished. But all the other pieces that we talked about are finished. On Jeremy's tree, it needs badly to be rebased, but the rebase effort is delayed on the stuff he talked about in his previous talk. The kernel SMB2 server, the SIFT, has fairly minimal implementation of these POSIX extensions, but it does negotiate the context and do some parts of this. And as I said, these other vendors, the testing we did a few weeks ago was fairly minimal on this, but it looks like because we made the right decisions in retrospect,
Yeah, they're easy to implement.
the number of things they have to do, I want unlink to obey POSIX, not Windows semantics. I want delete to obey POSIX, not Windows semantics. I want case sensitivity. These are so easy to map into these semantics that it hasn't been hard for these vendors. And why isn't it shipped?
Well, so essentially I'm blocked on finishing the VFS rewrite, although Volker has actually been helping me. Mostly it's like, well, I have to do the VFS rewrite first, but mostly it's actually a blocking of time. So if someone wants to come in and help rebase the tree into the current Samba master, we can actually do this in parallel. It's not. Basically, I was putting out my project timeline rather than if I get more help, we can parallelize this, and maybe we can get the POSIX extensions in at the same time, which would be good, which would be nice. There's still one or two decisions which we're waiting on Microsoft to provide information on to make sure that we're using the right types of repass points. What we're planning to do, rather than expose anything weird for Windows clients, for things like FIFOs, symlinks, block and character devices, we're going to return these as things that Windows clients actually understand, which is repass points. And that's actually a really nice decision because Windows already has a way of storing weird things that the client doesn't understand. So if it stumbles across something like this, it just basically says, hey, this is a file system object type I don't understand, I'm not going to do anything with it. But it then allowed us to reuse that mechanism because essentially people can put anything they want in repass points. It allowed us to reuse that mechanism and stay within the parameters of the existing SMB3 protocol to add the pieces that Windows doesn't currently do.
And one of the tricks was which tags do you use? So if you look at these reparse, if you look at these reparse tags, you don't want to reuse. You don't want to accidentally collide with somebody's. I mean, this has happened in SMB1.
You don't want to create your own.
When HP and SCO and other companies kind of forked their own, right? So Windows had reserved for WSL a separate tag for each special file type: FIFO, care device, block device. And that was something we found about the details about back in last August. So this was a minor change. But what this means to you, it allows us to optimize read-dir. When you do a query dir, you can do one query dir, get the information back without having to say, oh, that might be a symlink, it might be a care device, let me do an extra query for each reparse point. This allows us to just do the one query and now we know the file type. And, you know, that was, the details are what has been documented, although it's in an addendum, so it hasn't, you know, I guess the new version of the document comes out probably this summer, I guess.
I don't know.
We need to ask the doc help guys, but these tags were reserved a year ago, and they're documented, but there's not much interesting in the payload except for, I guess, the care device maybe, or the block device maybe.
And the main thing is, these are the tags that the Microsoft Windows services for Linux, or is it Linux services, whatever.
That's what they're already
That's the one that they use when they're storing POSIX style things on the NTFS file system. So the goal is, again, not to invent anything, to reuse what's already there. Now, one of the confusions is they previously had a method of storing these things which they used for the NFS server, which was services for Unix. Lots of services for names. Anyway, so we were originally going to use those, but I think WSL is the more actively developed project, so we should probably standardize on those.
Yeah, and more importantly, the NFS one had an NFS tag, and then we had to do an extra query to figure out which one it was, where these are separate tags for each. The only time we have to do a separate query is if you're doing a stat and you want to find the information about the block device, for example, or you want to find the target of the symlink. So the beauty of all this is it does save the round trip. And these are reserved already, and they're shipping in, 100 million systems already, right? I mean, so
the other
there's no
thing,
risk of collision.
The other thing that we decided on, and I know this is going to cheer Christoph up immensely, no POSIX ACLs, only Windows ACLs. Essentially, if you want to do a chmod on a POSIX file, you essentially send a Windows ACL set with a special set of types, special set of SIDs, and we decided not to do POSIX ACLs to standardize with NFS v4, which again is very similar to Windows ACL, standardized with ZFS and the others. And so essentially, you don't have to have two separate ACL models with two separate user identification mechanisms stored in the code. Everything is Windows ACLs. Like it or not, that's the model that won. Mac uses it, Windows uses it, the SMB3 Unix extensions will use the same model. We're running out of time. NFS uses it, yeah. We have 5 minutes before.
Okay, so the examples are very easy. How do you use it? So the key thing, you really only have to specify one thing, POSIX. I like using MF symlinks, despite having my name in the MF symlinks, the Mac style, because those are only affect the client.
They're user space. They're client-side.
They're client-side. So the reason that we talk about MF symlinks, even though technically the extensions could support it, is Jeremy has lost so much hair, so much sleep, so many years of his life he's lost on symlink security bugs, that having symlinks that have no security exposure on the server is a nice thing.
Yeah.
No map POSIX we talked about because obviously
Why would you ever have symlinks on a server? I mean, that doesn't even fit the definition of a symlink.
They may be on the file system that you're exporting. That's the thing.
Yeah.
Yeah, but only the client is interpreting them. I mean, the server, the whole idea behind the symlink is that it's opaque to the file system.
Well,
except but it isn't. Anyway.
Well, so imagine that you've got Ganesha or you've got the NFS kernel server. You're exporting Samba and you're exporting an NFS. The NFS guys create a symlink. It exists on the server.
Yeah.
And neither the NFS server nor Samba should do anything about the content.
Yes, and that's easier said than done.
That's a good plan. And part of his life is making sure that there's no place ever where this will happen. But it is tricky because Ganesha's not perfect. Samba wasn't perfect until recently. So on the server side, set SMB to Unix extensions and smbconf, mangled names equals no. And there's also this obey PAM restrictions, which is a kind of obscure thing that you want to make sure you remove. These are relatively minor changes to put in your smbconf. And on the client, POSIX and no map POSIX, very easy. So directory and enumeration, here's the example we talked about. As you're enumerating the directory, here's the tag that tells you what it is.
All right. We're running out of time, Steve. We have 2 minutes, so let's keep going.
Good. So query directory, very easy, works. Without extensions, there are many things that can work with emulation, sysacl, and others. But what I want to focus on is with these extensions, you get the POSIX semantics on unlinked, delete, case sensitivity, which means a lot of apps work. Building the kernel is a little bit easier. There's lots of things that expect these POSIX things, even though they're so small. Now, we also need to be able to quickly update these because we're expecting that Dave Howells is going to continue adding API calls, and we're going to have to keep figuring out ways to extend this. Those new stuff that'll be coming. This is obviously a first pass at it, but over time, because of the way we've designed it with the create context and the open context, it's going to be very easy to extend.
So we could have a different create context saying, okay, here's POSIX plus, basically.
And the other thing we've talked about in the future is the tree connect, allowing that when we mount the share, have it one export POSIX and one not. We already can do that, but this will allow it to advertise it better to the client. That's one thing we've talked about for the future. And there are specific requirements about the lock, like the OFD locks, for example. These are OFD locks, not POSIX locks. These are things we can go into. But the one thing I did want to emphasize is we also want globally identified users. So we're returning the SID. you're responsible for mapping that into the local UID on the client.
Yeah.
On the server, you're responsible
Or-
for mapping it how you want.
If the server is in an active directory domain, we'll just be returning the SIDs that you would normally get.
Yeah.
So you can have a unified namespace based on SIDs from an active directory domain.
But the UIDs passed are globally unique. You're responsible for mapping them on the client and the server. The info levels are quite easy. Two quick things. Wireshark has been, here's a Wireshark tree. If you want to go look at the Wireshark traces, it's very small changes, but this makes it easier to read. And also sample test code that Aurelian at SUSE wrote for Pike.
And we have 1 minute, so let's go.
So next up, we got to keep debugging at these test events. There's a wiki with the details in the presentation, and we're going through test by test by test and XFS test, trying to see what we can enable. And then, of course, waiting for Volker and Jeremy to finish this.
We'll know we're
update to Samba.
successful when we can basically diskless boot Linux machines from over SMB3 from a Samba or.
Well,
kernel
so we've
server.
already declared success then. So about
Well, you have with SMB1.
No, but this is what was so cool. So 2 weeks ago, I was talking with the SUSE guys. Paolo at SUSE was booting diskless machines off SMB3. He figured out a way around it. So,
Cool. Oh,
yeah,
we're
so-
done. Haha.
Anyway, so
All right.
a lot of this went into the 5.5 kernel to
Okay.
diskless boot.
So, and we're out of time. Any questions or? All right, you can grab us in the break. All right, and thanks very much.
Yep.